Hi, I'm Hugh from SRI Instruments, and today we're going to show you how to take apart the electronic pressure controller, the EPC, in case of a malfunction. So, if we've decided that there really is something wrong, even after kind of looking around, making sure there's no problem with the gases, then it may be time to open the GC and do some kind of maintenance inside. So, we'll unplug the GC and then remove the 6 screws from around the bottom plate. I've only removed one here, but that's just because we're saving time. So then you can tilt the GC on its back. It's very comfortable on its back, and then you can see inside the GC. There's a ground wire here that I'm going to remove. And then I'm going to tilt the GC back on a little pillow that I've made so that I don't scratch the lid. So this thing here is the electronic pressure controller. In this particular GC, there's 3 of them. One for the carrier gas, one for the hydrogen for the FID flame, and one for the air, which also goes to the FID flame. So we're going to just remove one of these. We'll remove the carrier gas one, and then we'll show you how to put a new sensor in, and then also how to do a little diagnostic maintenance on the circuit boards. There's 2 circuit boards in this GC that control these 3 electronic pressure controller. Pressure controller is really just like any other mechanical pressure controller, except there's a sensor which is hidden behind the EPC right here, and the sensor goes to one of these circuit boards which reads the pressure, and then the board sends out a control signal to the EPC to either go up a little bit or down a little bit, so it keeps the pressure very constant. Plus, they're small, so they can fit, we can fit up to 7 of them in a GC, whereas there'd be a lot of front panel space devoted to gauges and control knobs if it wasn't so compact. So that's the main reason we do that. So if for example, we decided this carrier gas electronic pressure controller needed to be replaced, we'd pull this little buffer coil off, and we see that the EPC consists of a black solenoid and a brass manifold. So we need to remove the whole thing from the GC. It's held in place by 2 5/64 hex head screws. So I've got my little 5/64 hex wrench, and I'm going to remove this screw, and then remove this one here, and I'm going to hold it so that it doesn't drop or crash into something. And then when I pull it away, you can see that there's a pressure sensor attached to the EPC. So if we're going to change this EPC, then we need to remove the pressure sensor. So that's a 7/16 inch wrench. And notice one thing about the way the pressure sensor is mounted is that the shortest side is aligned with the face here, because if you don't align it that way, when you put it back in, the sensor will crash into the wall and break. So you have to have it aligned with this. So note that orientation before you remove it. Maybe you want to put a little mark on it or something just so you remember. So you put a little Sharpie mark on the side facing the inside of the chassis, just so you can't forget. So then we're going to remove the 1/8 inch swage lock nut. And now the pressure sensor is separated from the electronic pressure controller. So I'll just leave that hanging there for a minute. It's fine. And then we'll do a little cutting of tie wraps so that we can move the wires around a little more easily. Hopefully you have some tie wraps that you can use as replacements. But just to make it clear, I'm going to cut a few of these tie wraps so that we can So you see how the sensor, the pressure sensor, is on a connected to a phone cord, and the phone cord is connected to a jack on this circuit board, right? So it's a phone jack, just like in the telephone at home. So you just pull the connection out, and then, so if you were just replacing a sensor, that's what you'd do. If for some reason we had sent you a new sensor, we thought it was bad, you'd do exactly what we did here and just replace the sensor by plugging the new sensor in like that, and then attaching the new sensor to the EPC solenoid. But of course, paying attention to that orientation, because that's really important. It's expensive when you break one. So that's the sensor out of the way. And now we have the solenoid itself, which is also on a wire that's connected to that circuit board. So I'm going to just pop that connector out, and then I have to remove two things. I have to remove the gas connection here. So that takes a 7/16 wrench and a 5/16 wrench. So I'll put there and remove this connection here. So now the EPC is just really attached to a black wire that goes to this, what we call a chassis ground stud. It's basically the ground of the GC. So everything is connected to ground in some respect, except for the high voltages, but all the low voltages are all referenced to this chassis ground stud. There's another one of them here, a bigger one, where a lot of these circuits all have a common ground. But you see how it is? It is just a little ring that goes on there and then screw down. So that's removed, and that's typically as far down the assembly chain as we go. In other words, we don't think this is really fixable. If it's clogged, is what usually happens, is that particles go in and there's a very small hole that gets clogged up, and it's really not practical to unclog it. There's an occasional exception to that, but for the most part you have to buy this if that's bad, and if it's the sensor, then that's bad. So what happens if the diagnosis points to the circuit board being bad? Well, so let's take the remaining phone cord out of this particular circuit board. This one goes up and lands up at the front of the GC, so that when you push the button you can read the pressure. So this is how that signal gets up to the front of the GC. We call that the display board. So this would be the display board connector. So I'm going to take this circuit board out of the GC. So there's two screws from the back that have to be loosened. That's another reason why it's kind of handy to be able to tilt the GC back. So I'm going to remove those two screws. And then there's one more screw that's a flat head screwdriver. These two were Phillips heads, but this one you have to poke it, have to have a long screwdriver that's long enough to go all the way through, because it's a tight fit, and then turn this screw down here, which is a captive screw. It meaning that it's not going to fall out. It's held in place. You can loosen the screw, but it's going to come out with the circuit board, right? So now I can kind of maneuver that circuit board out of the GC. So these circuit boards we call them EPC boards, for electronic pressure control boards, right? And there's two of these EPC boards in this GC, and they're both identical, except in this one there's two control zones that are populated on the board. In this one it's the same exact board, but only one of the zones has been populated, and that makes sense because there's only three EPC solenoids to control. So it's expensive parts, so we don't populate it unless there's something to control with it. But what this enables you to do, because these are identical boards, is that if you suspect that the carrier gas circuit board is bad, then you can unplug the connectors from another circuit board, like this air control circuit board, and just plug the parts into this other circuit board, and that helps you diagnose whether the circuit board itself is bad. Because if you have the same problem on two different circuit boards, then it's probably not the circuit board that's at fault. It's probably whatever's connected to the circuit board that's at fault. So to reassemble this, especially if it's tight in here, because some of these boards are pretty close to each other. They have to be in order to cram all this stuff into a small box, but sometimes you have to remove one board in order to get access to another board, and that's perfectly fine. You can see how they just dangle by the wires. So if you're comfortable working around electronics, then you'll find this very understandable, because you can just figure out where everything is pretty much just by looking. But just to make life easy, I'm going to plug the circuit board in after I put this stuff back in, right? Because that'll make it easier for me to plug it in. So if you purchase a new one of these solenoids, it's going to come looking something like this. The green color means that it's got the right sized hole for the carrier gas, so that's 8/1000ths of an inch. The red one is got a smaller hole, 4/1000ths of an inch for hydrogen, and the black one has a bigger hole, 20/1000ths of an inch for air. It's got to do with the viscosity of the gas that you're trying to control, and you want the hole to be the best size so you get the best control. But there's no connection on the end when you get a new one, right? So this one has a little connection here, and it's been cut short just because when we put the GC together we try to be neat. But you don't have to be. You can just use the whole thing without cutting it. But you do need the right size nut and ferrule, right? The right size nut and ferrule is a 1/16 inch, could be brass or stainless, doesn't really matter. It's brass or stainless swage lock fitting with either a 2 ferrule swage lock fitting or a 1 ferrule fitting from another manufacturer. It doesn't really matter, they'll both work. But we'll have to connect the end of this tube to the place where we disconnected the previous one, right? So we'll be prepared to do that. But the first thing I'm going to do is reattach the pressure sensor to the manifold, right? So I'm going to be careful about that orientation that we were talking about before, to see if I have the long side in the wrong place, it's going to crash into the chassis when you put it back together. So we're going to have to be careful to align it properly before tightening it up. So just temporarily kind of bend this out of the way, and then I'm going to put this in place, and then tighten up those 2 screws. Okay, I got one of them started. And let's get the other one. Okay, so that's in place. So then I can take my phone cord. Actually, what I think I'll do is just put this on there first. Okay, and then I'll drag the phone cord down and attach it to the circuit board, right? So the circuit board, this attaches in this jack here from the EPC. It goes to the one closest to the power supply. Okay, and then the sensor, I'm going to try to snake it down there alongside its other one, so they're all grouped together. And then I'm going to plug the sensor into the one here on the right side. It's labeled sensor. And then there's one more that is somewhere hiding that's coming from the display board, right? That's the one that goes and takes, so you can push the button and see what the pressure is. And I'm going to plug that one into the display board connection. Make sure they click and give them a little yank to make sure they're solidly in there. So now it's easy for me to put that circuit board back in place. So I'm going to take my captive screw. Let's see, is that the right one? I guess it's over here. Yeah, there we go. Okay, I got the captive screw there, and then I'll get and put the two little Phillips head screws in from the back. You have to wiggle it a little bit to get it to find the threads. Okay, so that's all back together. So the last thing is going to be, I guess there's another last thing, and that's we got to put the ground wire back, right? So that ground wire goes onto that chassis ground stud that we were talking about, and then there's a little flat washer, and then there's a nut with a lock washer, which I just dropped, which that's annoying. So I'll just continue by finding another one. But later I'll have to go back and find that one that I dropped, because I wouldn't want to leave that. Usually if you drop something inside the GC, you can just turn it right side up and shake it, and then it comes out, usually voluntarily. But if you know you've dropped something in, you really have to find it. Okay, so I've got the EPC all electrically connected, and now it's just this gas connection, which is longer than it has to be, but you can really just coil it up. So I'm just going to do that. I'm going to just take a bottle or something handy, and I'm going to give it a little bit of a coil just to make it look neat. And then that is going to have to connect to there, right? Because the gas comes out of this at a certain pressure, and then goes through these various coils, empty coils of tubing, and then off to the column of the GC. So we have to connect this with that nut. So that's a 1/16 inch nut, and then it's a very tiny little brass ferrule, which is also easy to drop, so try not to. And then there's a front ferrule. And all of that has to get connected to that fitting there. Right? So I've got it in place, I'm tightening it up, and then using a wrench to get it tight enough so it'll stay, and then putting on a bigger wrench, and then tightening it up until I can feel that the ferrule has squished. It's a feel that is hard to develop, but you don't want to go all the way as far as you can, because then it's too tight. So you want to tighten it enough so that it feels like you've squished that little brass cone inside there called a ferrule. And you should not be able to move the tube at all, no matter how hard you yank. You should not be able to. If the tube even twists, it's not tight enough. So it's a difficult skill to master, tightening nuts and ferrules, but if you do it right, then they don't leak, and that's the goal. So I think that pretty much covers it. So thanks for your attention.